Doing well. In this video, we're going to discuss a very famous system design problem. Check whether user is online and offline. It's a kind of design that has been used across multiple chat applications such as WhatsApp, Slack, etc. Apart from that, it has been used across gaming platforms as well. So yeah, without wasting your time, let's jump into the actual design. So in this video, we are going to have this agenda. We are going to talk about requirements. Requirements are, to be honest, pretty simple. We need to get a system where we need to find, whether a user is online or offline. Based on that, we are going to see what are required APIs that are going to be part of this specific design. And then there is component design, and we are going to dive deep into each of the component that we are going to use. So required APIs are quite straightforward in this system. It's going to be whether online and offline presence update API. So say I am a user of Slack or WhatsApp, and it would need some input from my end to send a heartbeat kind of API to share, hey, I am the user ID 123 and I'm available, or I'm still using the application. And second one is online and offline presence get of all users for a specific user. So it's basically to see if list of users or users from specific channels are online or offline. So these are two required APIs. Let's see how they look like. Update online status, this is the first API we discussed. It is going to be post. It can be used as put API as well. We created a post API so that for first update it will create a new entity or create a new record in the permanent storage. So post slash API slash v1 slash user slash specific user ID and heartbeat. For that heartbeat, body can be anything. We just want to say, hey, status is online for me, and then we're going to get a cool response 200 saying that, hey, everything is okay, and you don't have to, the API response is successful. No need to process further. The second one is get status of each users from a group or from available screen for a specific user. It's a kind of a difficult thing to notice. So let's see this with this an example. This is a Slack screenshot. I'm not sure how much is it visible, but if you see, say these are the users, these are the channels, these are again users. I need to see here, from these what are the available or online users uh, for my screen. Or if I select on each channel, for that channel I need to see, hey, in this channel, out of these many people, the person X is online, person X is offline, these kind of stuff. So for this, getting the status of online versus offline for available users, we use this API. It is going to be get API, API slash v1 slash user. For this specific user ID, we want to get all the status. A response is going to be 200 okay, with response format that is going to be array of objects, and for each object we are going to see, hey, for this user what is the status and what is the updated at time. So in this case, user 123 say status is online, it has been updated 2 minutes ago, something in terms of epoch. Obviously we're going to get the time in order to avoid the time zone conflict and all those stuff. So epoch time is something which is used as a gold standard across industry. So we're going to rely on that user ID, status, and updated at. These three fields seem genuinely useful. There can be other metadata as well, whether the user is part of channel and all the other stuff. But these three things are sufficient to consider, how this API is going to look like and what would be the responses of this API. Let's jump into whiteboard to see, how we are going to design this problem. To be honest, there are a couple of approaches to look at this problem. We'll see how each of the approach look like. So I am on my Xcali draw. I added already the text design for this online offline status reflection service. First approach is very straightforward, where we're going to do a constant status polling for a user. If you are aware about polling, it is continuously trying to evaluate, continuously trying to call the specific API. In this case, we are going to continuously call the status update of each of the user that are for the users after a certain time. So how this would look like is, let's say, let's start with the drawing part. Let's say this is application, uh, this is also application. So they reside on other side of API gateway. Okay, so if we consider API gateway to be this, saying that hey, this is the entry point of all the uh, API requests that are coming to the backend part. So this is the API gateway we're going to see. uh, Here, what we're going to have, after the API gateway, we're going to have services needed for this system. What service do we think would be available, would be required for this kind of design? One service definitely needs to be there in order to receive the heartbeat API. So let's say status capture service. Okay, yeah, I like this status capture service. Since it is a service and it is continuously going to get bombarded, not continuously, we can say that we'll get the API call for this. Uh, we can either consider it as a API call, or we can have a permanent Websocket connection as well. To begin with, let's consider a API, a REST API, and simple REST HTTP TCP based API, where we're going to call the heartbeat API every 5 seconds or every 10 seconds. That can be configurable. Okay, and that status is going to get updated uh, through this status capture service, and we're going to store it in the database. Since this kind of data is uh, kind of needed at access of this kind of data is kind of constantly updating and evolving, saying that hey, user was online at 2 p.m. but was offline at 2:15. The record needs to be constantly updated, and quick access is required for such kind of data. We can store it in memory database to avoid all the latency related issue related to file based database. So we can say that user status table. Okay, we can consider it as a in memory cache built on top of Redis. Okay, so it is going to update here, and then we are going to have another API. Okay, sorry, another service. Let's say this service is going to be responsible for sharing the status of specific user. So you can say that status uh, display service, status let's say broadcast service. Yeah, uh, okay, cool, this looks nice. Status broadcast service. What it needs to get, so it will get an API call for getting the update of specific, for a specific user. So for this specific user, I need to get statuses of users that are present in his or her home screen basically. So that plus the channel user online presence basically. That's how we decided to have in the design. The channel part can be skipped. We can consider getting status of channel users once user clicks on channel info, but that's fine. Eventually it is going to be a same thing. So you'll get the call to the status broadcast service. What it needs to do, it needs to read the data from user status. Okay, wait, it needs to get the okay, it needs to have its own database. What it will do, it will get the user home screen. Okay, who user channel table. So user channel table implies for what channel the specific user has subscribed to, and second table would be we can say user friends table. Okay, so from these two tables it needs to get the uh, user list for which the uh, status is required. Okay, 1 second. Yep, this looks cool. So it is going to query, hey, what are the channel this specific user has been subscribed to, which users are present in this user's home timeline. So once it gets list of all these, it is going to query on user status table. Okay, so let's say this is 1.1, 1.2. These can be queried asynchronously, parallelly, and after getting the list, it is going to check the status of this user list. Based on that, it is going to respond back to this API saying that, hey, for this moment, this is the list of this is the status of uh, user list in which you are interested in. If you think about it, it is very costly service in a way that it is constantly pinging, let's say after 5 seconds, especially the second one. For the heartbeat one, we cannot skip, except for the part that maybe we can set up a WebSocket in order to avoid the constantly uh, a request response handshake between for the TCP APIs. Okay, so we can for the TCP API, and we can avoid the handshake, and we can consider there is a WebSocket. We can improve on that and consider that, hey, instead of WebSocket uh, instead of constantly handshaking for each 5 second or whenever the heartbeat is sending the information, we can set up a WebSocket. And for the constant request response, we can consider, for that aspect as well, we can consider a WebSocket. So we can consider this approach using REST HTTP TCP based approach. Okay, we can improve on this with the WebSocket. You can say approach to WebSocket based okay. Only thing that is going to change is this is going to be a WebSocket communication. Similar to this is going to be a WebSocket bidirectional communication. And whenever WebSocket comes in, API gateway needs to have its sidecar uh, table that will match, what are the what is the user versus socket mapping. So we can say that user socket mapping table. Okay, so API gateway is going to have this requirement to, for which WebSocket this specific response needs to go back. Okay, so yeah, this looks fine. This is WebSocket based, no major update except for the fact that we were using TCP networking protocol here, and for approach 2 we're relying on the WebSocket. Let's see if we can improve it on further. Okay, so what we can consider approach 3, where we can share the update to the end user. So let me scroll back a little. Okay, so we can avoid this API and push the updated status to the user, in which he or she is interested in. So basically, uh, let's say there are 4 users. Let me write it down. So let's say there are going to be 4 users, A, B, C, D. At this point, A is someone who wants to know, out of B, C, D, what is the status of these users. So to begin with, it will call the API and get all the online status. But after that, it is not going to call the get status API every 5 seconds. Instead, it is going to maintain a WebSocket connection, and whenever, say after 5 minutes B gets offline, or after 7 minutes B disconnected with the internet, A is going to get notified that, hey, status of B is offline now. Here we are significantly improving upon the network bandwidth, where we are going to share the CDC, basically change data capture. If the status is updated in this user status table, then and then only we want to respond back to user saying that, hey, update the status, otherwise keep the status as it is. After say 10 minutes B again comes online, we are going to again send the response over WebSocket saying that, hey, user is online. The WebSocket is capable to have bidirectional communication. Hence, the usage of WebSocket signifies here, instead of we relying on TCP-based communication, because with TCP, only client is going to communicate with, like, initiate the query with the server, and then only server can respond back to client. It is not going to be case with the WebSocket. In WebSocket, even server can initiate the communication with the client saying that, hey, this is the new information you need to be updated with. So let's see how this approach looks like. So here again, as this part, let me take this. These are the applications. Okay, I really need to improve upon my drawing skills here. Okay, let's say this is API gateway. Okay, cool. So this is API gateway for which the clients are always going to maintain the bidirectional WebSocket. Okay, I'm not sure if it is able to give me. Okay, yeah, I need non-directional arrow to signify that, hey, this communication is only unidirectional. Okay, cool. So that's there. After that, what we need, again, we need to have the status capture service. Okay, so similar to this, let's take this status capture service and add it in our approach 3. Status capture service is going to do the same thing, getting that, over WebSocket. Instead here, it is going to get the information over WebSocket saying that, hey, this is the status for the specific user. Again, user status table is going to be same. Don't worry about the schema, we're going to discuss about schema once we have the architecture part complete. So this is user status table. Okay, so what we have now, so it is status service is going to update the user status table. Let's say for first time the status is online. For first 5 seconds the status is online. After 5 seconds status is offline. After 5 seconds status is offline. Now let's say after next 5 seconds, due to some network issue, or say basically the app crashed in the worst case, uh, the status capture service is not going to get any response saying that, hey, there is no call, or basically status socket is disconnected from the API gateway. It does not have any communication with this. It does not have any network communication with this device. So status capture service, since this is Redis based or in memory table, we can add TTL on top of each key. So before adding TTL, let's discuss the schema. The schema part is very simple. We're going to have user ID. Okay. Let's say user ID 123. Okay, user ID 123. Updated at epoch value. Okay, these two fields are sufficient. Now since it is going to have TTL, okay, TTL of let's say 10 seconds. Okay, let's say if within 10 seconds it does not get the value, updated at value is over the 10 seconds, like let's say value updated at value is t, current time is t plus 10, it implies the time span of this record has been completed. Redis is going to delete this record. So whenever we deletes the record, we are going to have the CDC moment. CDC is nothing but basically change data capture, if you are aware, or in SQL term it is also known as triggered based mechanism. So whenever the value is deleted, it is going to send a it is going to have the callback function to which it is going to call to. So from this callback function we're going to have the workers. So here workers is nothing but in terms of cloud technology, uh, serverless functions, or similar to AWS Lambda, where you don't have to spin up EC2 instance. They're going to be taken care by this serverless architecture based functions. So let's say this is the one of the serverless function we're going to set up with. Okay, with this, what information do we need? We need to get the TTL. We understand that, hey, the specific record for this user has been expired. So where we can name it as worker. Okay, captures user. Okay, shoot, I'm looking for better name instead of just saying worker. Okay, we can say pubsub worker. Basically why pubsub, we'll discuss. So what this pubsub server is going to do, it is going to get all the subscribed or all the users for which it needs to update the status to. Okay, so let's say, as we discussed here, right, previously in the approach one, it is going to need user friends table and user channel table. Similarly, these are the same table, user friend, or simply friends as well, right? Why to append prefix as user and channel. Okay, instead of channel we can name it as group as well. Yeah, oops, friends table and the group table. Okay, yeah, okay. So with this, it is going to fetch records of friends that it needs to send the status update to. Similarly, it needs to get all the groups where this updated status is going to be. Okay, so we have friends table, we have group table. Now what we need to have, we need to have the pub sub. So it is going to have the queue, let's say pub sub. Okay, where do I move it? Pub sub. Okay, so let's say this is pub sub broker, built on top of maybe Redis again. It can be, there are other solutions as well, but Redis does really nice job for the pub sub implementation. Okay, so it is going to have the pub sub broker, and from that pub sub broker we are going to publish this message. This message is going to get consumed by the status broadcast service. And from status broadcast service, this information needs to be propagated back to the user. So from group table and from the friends table, we're going to get all the users to which the status of the user needs to be provided to. We can have some optimization related to, uh, we want to send this information only to users that are online during that time. Again, with API gateway, we're going to have the sidecar DB where we have the user socket table. Okay, if you are not aware, do let me know how WebSocket works in actual production. I know there are a lot of theoretical concepts around, hey, this is WebSocket and that's how WebSocket communication works in general, or there are tutorials which do simple WebSocket communication and create a basic chat application. But when we look at bigger systems like WhatsApp, any chatting application, this WebSocket plays different role, not a different role, but really play a role where bigger architecture like API gateway and other components, even the specialized web server, WebSocket server needs to be needs to be provided, or AWS Lambda needs to be piped in order to consume the WebSocket messages. Let me know if you want to know more about that. So yeah, for the let's add the model for each of the table which were considered, and then close on this video. Okay, so friends table, for friends table, what is the information? User 1, user 2, created at, or we can say updated at. Okay, okay, so what this implies is user 1 and user 2 are friends. That's what this friends table implies. Group table implies to which groups this specific user is part of. So user 1, or we can say user, then we have group ID. Okay, if we want to go with SQL based database, here we can have denormalized data where user group ID makes the composite unique value. Okay, so user ID, user underscore group ID is going to be primary key. If we don't want to jump into relational database, since there is no direct joins or any complex query required, we can just play with simple key value store similar to DynamoDB, or we can even try to utilize document-based database such as MongoDB, where underscore ID is act will be act as a primary key. Okay, so in that case, we can even consider group ID as the uh, group IDs as the list of group IDs to which this user is part of. So G1, G2, etc. The pub sub broker is basically Redis based. We can say we can consider other pub sub uh, providers as well, such as RabbitMQ, but PubSub works just fine because it is in memory. There will be minimal latency involved uh, for overall workflow. Yeah, I'm pretty much satisfied with this design. Do let me know if you have any questions regarding this, and I'll see you in the next one. Thank you.